Hello everyone and welcome to my YouTube channel. Today I'm going to look at question 2, analyze the distribution below using moment distribution and the bending moment diagram indicating for the critical value. We're going through the steps for calculating this system. As you can see, for span AB, at the moment of inertia is 3I, for span BC, 2I, and span CD is a cantilever or an overhang. There's a point load of 8 kilonewton for span AB and a UDL of 20 kilonewton per meter for span BC. So the first step is to calculate the fixed end moment. Calculate the fixed end moment. This is the fixed end moment formula. For beam with the point load, the middle is PL over 8 or WL over 8. So the first convention that I've taken is clockwise moment positive and anti-clockwise moment negative. So for the first case, we're going to use this formula here. So when I'm pointing with the mouse. So if you do that, MAB is WAB squared divided by L squared. You get 80 times 2 times 1 squared divided by B squared, and you get 17.78 kilonewton meter. For MBA, it is the same. Positive WA squared 2 divided by L squared. You work out that, you get plus 35.56. When you go to the moment BC, we have a UDL with the formula WA squared over 12. To that, you get 20 times 4 squared over 12, and you get negative 26.67. MCB is basically positive 26.67. So if you work out that, you get positive 26.67. So the next step number 2 now is to calculate the distribution factor. We only have one joint, that is joint B. So if the far end is fixed, we use 4EI over L. 4EI over L if the far end is fixed. If it is an intermediate support, you use again 4EL over L. But since this one is there is an overhang here, this is a pin support, so this is not an intermediate support, so you use 3EI over L. Work out, you get 4 times 3 divided by 3, you get 4. 4 again here for BC, 3EI over L, you work out that. Get 3 times 2 divided by 4, you get 3 over 2. Summation of this is 11 over 2. So to get this is basically K over summation of K. So 11 over 4 divided by 11 over 2, you get 8 over 11. And here you get 0 over 11. So the sum of the distribution factor should always add up to 1. The sum of the distribution factors should always add up to 1. Next, you carry out the moment distribution. You see is also pinned and C is a cantilever. So you put in the value for the fixed end moment. For AB 17.78, BA 1.56, BC 26.67, CB positive 20.67. CD is a cantilever, that is 20 times 1 times 1 over 2 gets negative 10. And of course, this is 0. Next, we put in the distribution factor. So the distribution factor for fixed end is 0. There's no carryover on that side. So that's for B is 8 over 11, BC 3 over 11, and you have 1 and 0. Now you carry out the moment distribution. So how do you do that? You get the summation of positive 5.56 minus 26.67. That is a positive value, and therefore the distributed moment will be negative. And if you carry out, you get This is negative 6.45, negative 2.456. The auto balance moment at joint C is 16 point positive 16, so this one will be negative. So next we do the carryover. So half of this goes to this side. Okay. So we are going to be distributing on this side, carryover on this side. So half of negative 16 again comes to this side. Next, you do a balance. So the out of balance moment is negative 8.35. So if you do the distribution, you get positive 6.2 and 22.273. Next, we do the carryover. So half of this comes to this side. All right. And half of this again comes, no, there's no carryover on this side. So basically that's it. So you do now the summation for the final one. So it's positive 7.98. If you add this and this to that, you get positive 5.16. And then if you add all this, you get positive negative 4.16. You add this, you get positive 10. This one you get negative 10. And of course, this one is 0. Yeah, this value is 0. So next now is calculate the target moment. For span AB, the formula is WLAB divided by R. You work up that 80 times 1 times 2 divided by 3. You get 3.39. For span BC, WL square over 8. So that's 20 times 4 squared divided by 8. You get 14. Let's get the bending moment diagram. So the bending moment diagram will look something like this. So the sagging moments are positive, that is 53.3 there, and this one 40. And the holding moments are negative 20.98 here, 25.16 here, and 10, then 0.